Good morning. I am Professor Nayana Manori, working as Assistant Professor in Civil Engineering Department, SVIT, Bangalore. I am the course coordinator for Design of Pre-Stressed Concrete Structural Elements. In this class, we will discuss Module 1, Analysis of Sections for Flexure. The first problem. Compute the resulting stresses for a rectangular beam 300 mm wide and 400 mm deep, which is pre-stressed with a force of 600 kN at a constant eccentricity of 80 mm. The beam carries a UDL of 20 kN per meter over a span of 6 meter. The first step, write down the given data. The cross-sectional dimension of the beam they have given, that is width it is 300 mm, depth is 400 mm, and the pre-stressing force they have given 600 kN, which is acting at a constant eccentricity of, eccentricity value it is denoted by E, they have given 80 mm. And the live load condition they have given, it carries a UDL of intensity 20 kN per meter and the span they have given 6 meter. I will write down that figure, the section of the beam, the cross section and the longitudinal section of the beam. See, this is a rectangular beam. This is the neutral axis. Below the neutral axis, you are going to place the tendon. Okay, the magnitude of pre-stressing force they have given, and also they have specified that is in the problem with a constant eccentricity of 80 mm. It is understood it is a straight cable. Okay, eccentricity is what? From the neutral axis, the vertical height from the neutral axis to the tendon, that will be your eccentricity. That value it is 80 mm, and the magnitude of pre-stressing force they have given it as 60 kN. And the cross section of the beam, width it is 300 and the depth it is 400. Okay, assume density of concrete as 25 kN per meter cube. You need to calculate the resulting stresses at the top as well as at the bottom. Okay, first calculate dead load of the beam. Dead load of the beam, it is given by the cross-sectional dimension of the beam, B into D into length it is for 1 meter and the density. Substitute the value in terms of meter. Width it is 0.3, depth it is 0.4 into 1 into density it is 25. Then calculate the dead load of the beam, that is 3 kN per meter. 3 kN per meter. Next, calculate dead load moment. It is denoted by mg, that will be equal to dead load moment. Okay, see the live load condition, it is UDL. The standard bending moment equation, if a beam carrying UDL, it is WL square by 8. L square by 8. Here you are calculating dead load moment. The load it is dead load. It is denoted by G. Then the load it is 3. Then the span it is 6 meter. 6 square divided by 8, you will get it as 13.5 kN per meter. Live load they have given, that is 20 kN per meter. See the intensity of that live load, it is kN per meter. Then the live load moment, it is given by, it is denoted by MQ, that will be equal to WQ L square divided by 8. WQ it is 20 into L it is 6 square divided by 8. You will get it as 90 kilonewton meter. Sorry, this is not per meter, it is kilonewton meter. Then calculate the cross-sectional area of the beam. That is what? B into D. That is 300 into 400. The section it is what? Rectangular section. You will get it as 1,20,000 mm square. Then calculate section modulus. It is denoted by, it is a rectangular section. The section modulus at the top as well as at the bottom, it is same. ZB or ZT, that will be equal to BD square divided by 6. That will be equal to, substitute the value, width it is 300, depth it is 400 square divided by 6. Then ZB it is 8 into 10 to the power of 6 millimeter cube. Then calculate resultant stresses at top as well as bottom fiber. Stresses at top fiber, it's given by F superior, or you can call it as F top. It is given by P by A minus P into E divided by ZT plus mg divided by ZT plus mq divided by ZT. Substitute all the value. That is, P is 600 kilonewton. It is 10 to the power of 3 divided by area 120000 minus 600 into 10 to the power of 3. Eccentricity value it is 80 divided by ZT it is 8 into 10 to the power of 6 plus mg value, dead load moment 13.5 into 10 to the power of 6 divided by 8 into 10 to the power of 6 plus live load moment, it is 90 into 10 to the power of 6. 10 to the power of 6 is what? The moment it will be in kilonewton meter. While substituting in this F superior equation, all the unit it should be neither Newton mm or mm. That is 8 into 10 to the power of 6. Upon simplification, you will get it F superior, that is resultant stresses at the top, it will be 11.937 Newton per mm square. Okay, positive indicate it is compressive in nature. This is what your F superior. Next, similarly calculate resultant stresses at bottom fiber. Resultant stresses at bottom fiber. Resultant stresses at bottom fiber. It is denoted by F inferior or F bottom, that will be equal to P by A plus P into E divided by ZB minus mg divided by ZB minus mq divided by ZB. substitute the value, that is P is 600 into 10 to the power of 3 divided by 120000 plus 600 into 10 to the power of 3, eccentricity value it is 80 divided by 8 into 10 to the power of 6 minus 13.5 into 10 to the power of 6 divided by 8 into 10 to the power of 6 minus minus 90 into 10 to the power of 6 divided by 8 into 10 to the power of 6. Upon simplification, you will get it F inferior as minus 1.937 Newton per mm square. Negative sign indicated as tensile in nature. This is what your F inferior or F bottom. Next, you need to draw the stress diagram for both at the top as well as at the bottom. This is the stress diagram. First one is what stress diagram due to direct stress. It will be in the shape of a rectangle. It is what? Load by area. Next is what? This is the stress diagram due to pre-stressing force. Okay, you can observe in this equation. That is minus PE by ZT. Minus indicate it is compressive in, minus indicate it is tensile in nature, and positive indicate it is compressive in nature. Okay, this is the stress diagram due to pre-stressing force, and the stress diagram due to dead load. It will be in the shape of a triangle. Similarly, the stress diagram due to live load and the resultant stresses. You can observe here F superior at the top, it is positive. Positive means it is compressive. For the sign convention, positive means towards your left side, negative means towards your right side. You can observe here the vertical line is the reference line. Okay, F superior is what? Positive. I have shown that value towards the left side. Then the F inferior, it is negative value. I have shown the value as towards my right side. That is the sign convention. Tensile, it is negative towards your right side, and the compressive, it is positive towards left side. Thank you.